This is Target AD, Chapter 9.5, and it is...
He's going the distance.
Yep, you guessed it. The distance formula. Am I a dork or what? Anyway, you're only going to get worse from here on out, so get used to it. Anyway, moving right along, our objective for today: to use the distance formula to compute lengths of segments in the coordinate plane. Okay, something that you are going to already need to know, and hopefully you do, is the Pythagorean Theorem. For those of you that might need a refresher, that's the one that's a squared plus b squared equals c squared. All right, so we've got the distance formula that we're going to get into in a minute here, but let's look at the graph below. We're given triangle AOB, and we can determine that AO equals 4 and OB equals 3. You can simply count this if you want. Here we've got OB is 1, 2, 3. See? Right over here. 1, 2, 3. And AO is 1, 2, 3, 4. All right, so you could use a Pythagorean theorem and just say, well, 3 squared plus 4 squared equals the measurement of BA squared. 3 squared, of course, is 9, and 4 squared is 16, and when you add the two together, you get 25, would equal BA squared. And to find BA, we just take the square root of both sides and disregard the negative. Why? Because you can't have a negative measurement. Do not forget that. So BA would equal 5. Easy enough when it's from the point of origin, and it's an easily countable number like that. However, to compute any non-vertical, non-horizontal line, you can draw a right triangle and use the Pythagorean theorem. But the distance formula is easier. Okay, so this is the distance formula right here. We have the square root of x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared. And that's the square root of all of that. All right, so it looks more complicated on there than it actually is. Okay, so just like with slope, the order that you pick your x's and y's in does not matter as long as you use them in the same corresponding order. Meaning, if you have two sets of two coordinates, that if I start with the first x coordinate, then I have to start with the first y coordinate. Easy enough. Okay, so which takes us to Theorem 71, which states that if P, which is a coordinate x sub 1, y sub 1, and Q, x sub 2, y sub 2, are any 2 points, then the distance between them can be found with the formula. Again, x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, and that is all under the radical. You can write it simply as the difference of x's squared plus the difference of y's squared, all under the radical. So, just 2 ways of writing it. Thought I'd introduce this little symbol there for you. All right, so let's do a little bit of practice with it, because this is pretty straightforward. Okay, you've got one formula to remember and one theorem about it, and you're not going to use the theorem in any kind of proof. So, let's say that we have D, which is 7, 1, and E, which is at 9, negative 5, and F, which is at 6, negative 4. And we need to find the length of the median from F to DE. Okay, so now the first thing you need to remember is that a median goes to the midpoint of the segment opposite the angle. Okay, so use a midpoint formula. That was the one that was x sub 2 plus x sub 1 divided by 2, and that would give you your x, and your y would be gotten by x sub 2 plus x, or not x, y sub 2 plus y sub 1 divided by 2. In this case, we need to find the midpoint of E and D. Okay, so we're adding our x's, and here the order doesn't matter because we're adding them. When you're adding, order doesn't matter. When you're subtracting, it does. So we've got 9 plus 7, which is 16, divided by 2, which gives us that 8. So 9 plus 7 is 16, divided by 2 is 8. And then we've got negative 5 and 1, which is negative 4, divided by 2, is negative 2. So that's the median, okay? And now we can use the distance formula, because remember, we're going from F to the midpoint, basically, of DE. Now, I know this might be kind of hard to visualize, so if it helps, draw yourself a diagram. Okay, so we've got, triangle, and we know that we're going from F to DE. All right, and I know this isn't where the points are, but that's just one way that you can think of it. Okay, so we take our points, x sub 1, x sub 2. It really doesn't matter as long as they're corresponding. So I'm using this one here and this one here. So I'm starting with this. So this is my x sub 1, so that's going to have to be my y sub 1. X sub 2, y sub 2. So I did 6 minus 8 squared, which is negative 2 squared, and negative 4 minus negative 2. Okay, when you're subtracting a negative, remember it's like adding a positive. So negative 4 plus 2, which is negative 2 squared. So that gives us the square root of 8. Because remember, anytime you square a number, you always get a positive number. So negative 2 squared is 4. Negative 2 squared is 4. 4 plus 4 equals 8. But that's not a simplified radical. This is. Because remember, 8 breaks down to 4 times 2, and 4 is a perfect square. So we take the square root of 4, pull it out, get the 2, and root 2. So that would be the length of that median here. Okay, so again, that's just one way that you use a distance formula. All right, now we're going to use the distance formula to show that triangle DOG is an equilateral triangle if D is at 6, 0, O is at 0, 0, and G is at 3, 3 radical 3. So, again, notice I'm not using any diagrams here. Some of these you might not have them, so you've got to get used to either drawing your own, visualizing your own, or just realizing that you really don't need all that information. So we're going to have to use the distance formula 3 times, and if done correctly, the distance between each of the 3 pairs of points will be the same. So I start with D and O. 6 minus 0 squared plus 0 minus 0 squared. Okay, that basically means nothing because 0 minus 0 is 0, and 0 squared is 0. 6 minus 0 squared is 6 squared, which is the square root of 36, which means that the length of that side is 6. Now, I'm going to use D and G. So I do 6, I'm starting with this again, 6 minus 3 squared, which is 9, and then 0 minus 3 radical 3 squared, which negative 3 radical 3 squared, remember, always still going to give you a positive, so you've got to square these separately. 3 squared is 9, radical 3 squared is just 3, so 9 times 3 is 27. So 9 plus 27 is square root of 36, which again is just 6. And last but not least, O and G. So 0 minus 3 squared, which again is 9, 0 minus 3 root 3 squared, which is 27, which again is going to end up giving us 6. So the length of all 3 sides is 6, and since the distance between the points that make up all 3 sides are equal, it is an equilateral triangle. So it's pretty easy stuff, right? Not too hard. Just make sure you keep your X's and Y's in the right spot, mind your P's and Q's, and be glad that SAS, ASA, SSS, HL, and CPCTC are all MIA for this unit. BTW, if you are stuck, just ask WWHD. In other words, what would Higgins do? KK, TTYL.